Yeah.
home is starting to now get back in because I've been away from home since last Monday.
Yeah.
And I can't get Africa, so it's like.
All right, for the people who are remote, can we get a confirmation that the audio is coming through? Hello, that bodes poorly. We have Gory. Hello,
Yeah,
Gory.
that works.
Brilliant. Thank you for joining us. Okay, so we have our other EDMer chair, or program lead, rather.
Hello.
Okay, I think we're good to get started. And I think, yeah, we're scheduled until 9:20. We want to be respectful of people's time going to the next sessions, etc. You can join. Oh,
Well, I guess
yeah. I guess there's not a on-site queuing tool. It's fine. We don't normally do a blue sheet for program meetings. All right. Welcome everyone to our meeting of EDM, the Evolvability, Deployability, and Maintainability IAB program. So just as a recap to some of the work that we've done in this program over the past, mainly been focused around a couple documents that Martin had actually started previously. We had our use it or lose it draft that talked about the importance of active use and mentioned things like greasing that I think are still coming into the discussion today. And then very recently, we finished up work on the protocol maintenance draft, and we've had some lively discussions along the way, but I'm happy with how we have improved that document. Some of the other stuff we've done is trying to work on how can we help encourage deployability via implementation testing and understanding status and tracking, and that relates to some of the stuff that Charles is going to talk about. We've done things, some minor initial steps like adding tags to data tracker so you can track implementations, etc. But I think we want to continue that discussion. So today, for the agenda, we don't have any slides. So this is meant to be very much just an open discussion, so we can kind of go around and talk about things. But the kind of three high-level topics that I wanted to cover were first, kind of continuing a discussion we had last time in a virtual meeting about greasing and just kind of understanding, where are we at with it? Is there anything that we can say about how effective it's being, or if there are useful things that can be done to understand what are the right ways to use in best practices beyond what was said in the use or lose it draft. There's another topic that I don't know. Oh, Lucas, you're here. Another topic that Lucas and I have been chatting about, and we said, this may be interesting to raise up to EDM, talking about, how we validate kind of our interop and deployments in different types of network conditions and how that can reveal different sorts of bugs. And then we also have an update from Charles, who's written a document on how do we find code and stuff. And so we want to reserve the last 20 minutes or so for that discussion. So if that sounds good to you. Oh, you go for it.
Yep. And just to remind everyone, the note well applies. We don't have it up on the slide, but it's never big enough font that you can read it anyway. As a reminder, everything that you say in this meeting is covered by the IETF note well, which means that the IPR policy applies and the code of conduct applies. So as usual, be nice to one another and have a friendly discussion. Even you, Colin.
All right. So let's get started with the greasing discussion. I'll just try to summarize what we talked about on our last call. And then I have a couple thoughts, and then let's just kind of go around and chime in what we think and tell me where I'm totally off base. So last time I've kind of been raising some questions. So specific to greasing. So greasing, I guess everyone's familiar with what we're talking about for greasing? Yes, I imagine so.
RFC 9170, just go and read it.
Yeah, there you go.
For the remote folks, that was RFC 9170, if you want to be more familiar with TLS grease.
Exactly. So last time we were talking about, what protocols are actually using greasing, have actually defined it. We talked about, are there ones that are not doing it that maybe should start doing it? We raised the question of how do we measure if greasing is actually effective or working? And we talked about some of the limitations of, there's only really a certain category of issues and ossification and bugs that greasing can help with, and there are lots of other things that it does not. Some of the specific examples here, I think we talked about things like MLS, which has been kind of recently completed. I don't think in that document or in the MLS documents they have anything explicitly about greasing, but it's something interesting where potentially they should have some greasing, or we could have some extra documents that talk about how to add it. I think it's important to note from that previous discussion that greasing code points specifically of using random values that you send every now and then is only one dimension of greasing. There are other things like the order that you do of TLS extensions, other types of behavioral changes which also are important to grease if you want to prevent ossification. And we also talked about the fact that some categories of greasing, like if you're greasing fragmentation, can be very harmful to performance and not something that you actually want to do in practice for real users. And so that does put some limitations on it. So I think the question that I have, and we can, people can discuss any part of this if they want, but is there something beyond what we already have in TLS documents or in Use It or Lose It that would be useful to write down as advice or insight, essentially some guidelines for greasing effectively that can make recommendations for how we do allocation of code points, if that is what we're doing, explaining that it's not just about allocation of code points, that you want to change other behaviors, etc., when you are greasing implementations. This could be something potentially that we could refer to instead of just pointing people back to the TLS document if we're trying to tell them to use this in lots of other ways. We can also point people to Use It or Lose It, but it's not quite as direct on practical advice for specific protocols. So what do people think? You can just grab a mic, or if you're remote, you can jump in the queue. David.
So I just had some thought that popped into my head because I kind of forgot about this when last time we talked, or it probably hadn't happened yet, so MLS is almost out the door. And when we had our EDM call, we noticed we were talking about grease, and went and looked at at MLS, and they didn't have any grease. And we had a conversation with the authors, and they added it, which I think is really good. But it took a lot of back and forth to kind of explain exactly when and how you grease. Like there's an issue, a GitHub issue, and I realized that for folks here that have implemented grease, we know exactly like how to do it, what it means, but it is not crystal clear. And I think the TLS document doesn't explain all of the details, such as like you do not treat grease code points differently on the receiver is a fundamental value of grease, and that's not as crystal clear as it could be. So I think there might be some value in adding that personally, or as in writing that up somewhere.
What do you mean specifically by not treating it differently on the receiver?
So when the part of the conversation they were saying, so you're saying that in our code, if value equals 0x grease value, then break out of your switch loop and continue.
Yeah.
Which is the opposite of what you want for grease. And so tools like JA3 do exactly that, but also they're holding it wrong, and that's kind of maybe we don't need to dive into that detail because their whole point is not to implement the protocol properly. Go ahead, Martin.
You just mentioned JA3. I think that's enough. But I think that fits pretty well with my experience here as well, in that I've reviewed a number of changes that involve grease at some level. And often it's the people implementing grease that write the code and the tests. And the tests need to know about grease, but the code doesn't. And often what happens is the code is taught about grease as well. Not just to generate it, but to do something special in receipt. And I just read through 9170, and it unfortunately does not address this point either. So there's a gap.
Yeah. Lucas. All right. Okay, so it sounds like there are things that are not clearly stated that we're having to, go and remind people in GitHub issues, et cetera. So maybe having something to read that is succinct and helpful could be useful. Other thoughts people have?
All right. As people get in the queue, another musing. Some folks in the Quick community might remember when I did chaos protection. And that is something that might be considered grease or might not. So let me explain. So in Quick, the first flight that the client sends is not encrypted. Well, it's encrypted with keys that are in the spec. So you can consider that not encrypted. And so it sends this TLS client hello in a crypto frame, which is just kind of, it says this is a stream. Here's your offset into the stream and the length, and then here's a bit. The way everyone implemented that was kind of the logical way, where your first packet contains exactly one frame, and it's a crypto frame with offset 0 and the length of your client hello. And then we had a bug because some vendor was complaining that a change we made broke their YouTube 0 rating, which I don't personally love as a concept, but that means that people then talk to my employer and complain to me. Then I care. And it took us a while, and we finally got in the room with the people who had written the code, and they said, oh yeah, we look at the TLS SNI, so the name of the server you're talking to, and how do we find it? It's just at a fixed offset in the packet. I'm like, wait, no, that's not where it is at all. This is a whole sequence of TLVs and frames, and you're not parsing it, you're just looking there. So I got very annoyed because, of course, this escalation made my life very difficult for a while. And I said, well, how do we prevent people from doing that? So then I got creative, which is always a terrible idea, but often fun. I took the crypto frame, cut it up in like a random number from 2 to 12, so that you would have like offset and lengths, and it's just cut up. Then I randomly swapped them, put a bunch of padding here and there, a ping frame because I could, and then I put that in the packet. And so that broke all of those implementations, but by the time they were fixed, we haven't had a problem since. And so that was a fun thought exercise, and we had people show up on the Quick Dev Slack saying, hey, is this packet legal? And it was really funny because a bunch of the Quick enthusiasts jumped in and went, well, this is bizarre, but yeah, checks out. That's a legal packet. And I don't know if that's not really grease in the sense that it's not about the registries, but it kind of takes the joint that we have of that packet and just turns it in every direction, make sure it doesn't break.
I think that counts as the stuff that is grease.
Yeah, that's what Colin says, bacon fat, and I like that.
Lard, it's lard.
All right, lard, much better. But I'm sure there are a bunch of other techniques in this space that could qualify if we decide to write a document about this topic, of things that are useful.
So highly related to that, just Matt Joris Meta. So we have similar problems, not 0 rating, but so first off, our Quick we don't use the standard version. So we've kind of deliberately not switched to version 1, mostly we were like, oh, this is a good thing to do because we don't want people to assume that everything is version 1. So we have like, our own code point that we run on the internet, and we're like, yes, we're very proud of ourselves for doing this, blah, blah, blah. But so we occasionally run experiments where we will switch the version because we can arbitrarily control it on our clients. And most of the time this worked fine, but then sometime last year we ran an experiment where we switched the version, and the new version wasn't doing anything different. The only thing it was doing was we were just swapping the version. It didn't do anything functionally. The code is the same. But when you look at the metrics for this experiment, everything was wildly improved and things were amazing, and like videos were playing so much faster and all these great things were happening, and we're like, what the heck is going on? And it turns out what's going on is that when you're a large content provider, people will apply policies to your traffic based on SNI, and if you change things in the initial, that, like, say, the version or the salt or things like this, all of these boxes that are applying these policies no longer can apply them. So this sounds kind of amusing in principle, but it also is actually kind of existentially bad to a certain sense, because if we want to, for example, get deployment experience with a new version of Quick that actually has functional changes, we can't do that unless everything in the middle is going to treat it the same as everything else that came before. So, for example, if we wanted to experiment with like a Quick version 4, right, that has some crazy changes that are functional, we have to get cooperation from everybody in the network to say, oh yeah, you got to throttle this too, and you have to understand the SNI, or come up with a different way to throttle us. And it's not even just version. It was other things like we started attaching the token to initials, and that broke a bunch of metal boxes and broke throttling. And so it's like, it sounds weird because like we usually think about ossification as like, oh, they're going to start blocking Quick, and that's bad. But this is actually the opposite. They stopped throttling Quick, but it's equally bad insofar as we lose all of our signal about what we actually did. So if we did something bad in the new version, we don't know that anymore. We can't tell. And I don't really know how to reconcile this, because the only solution is like basically you either have to get everyone to, throttle differently or do with their policies differently, or you have to accept that anything that's in the clear is in the clear forever, and you just have to leave it there. So this kind of fits into grease, which is that like we are greasing, but actually when we grease, like we it doesn't actually teach them anything, right? The feedback loop time is way too long. Like it took them over a year to fix one of these problems, they being the random vendors in the middle. So, but it's very similar to the point David's making.
Yeah, I think it's really interesting for both of these points that it's grease. Sorry, Dave. You need to.
There we go. How about now? There we go. I think it would be useful to have a document on, I'll call it lard, right, which is more than just the classic greasing stuff. We've heard a couple things here. 9170 is, of course, fairly short and only covers a particular case. We've heard a couple other cases here, and of course, going into details about, TLS is very TLS specific, and so if there's something that talks about lard in general, the other topic that I think would be useful to discuss, besides the ones that I've heard, which I think are all great, like David's example was, ordering, which is not changing code points, it's, maybe changing the order of extension headers or whatever it is that's relevant in the particular protocol. But I would say the relationship to fuzzing, right, because a lot of these same questions come up. And fuzzing is often thought of in an API sense, but you can fuzz test protocols, right? But often people think of, okay, if it doesn't crash, then it's good, right? And so if you say there's some things that greasing is meant for, like is to ensure extensibility, there's things for reliability, but they're all related techniques, right? Because if you can fuzz test a protocol, you might be fuzz testing in a particular way that it also counts for greasing or lard or whatever. And so I think having a common document that talks about greasing, changing orders, changing other things, and the relationship to fuzz testing, because it also helps you for reliability and security and these other things, would be a great extension to a document for the script to do. So, thanks.
Cool. I was just going to make meta comment here that across both of these examples, it's interesting that we've normally thought about greasing for like, ossification of things that are just like blocking, but both zero rating and the stuff that Matt was talking about for throttling are performance related and like something that you wouldn't even necessarily notice as one connection being broken, etc. It's just like everything is just slightly changing behavior. So I think it's worth calling out. Do you want to go for it, Jared?
Yeah, Jared Monch, Akamai. What we end up seeing our customers doing is, because they tend to own and control the application that lives on a lot of the devices that do this, is they actually do a lot of this. They do a lot of their own telemetry, either from if it's streaming or or whatever, to go and get the data on it. And I think there's an interesting question of, do we want to be looking at standardizing some of those telemetry methods as part of these whenever you're going and changing and extending a protocol, and actually be just have passive data that's available to understand what those characteristics are, because it's generally a performance degradation, or as mentioned, a performance improvement, because it bypassed the zero rating, which may have ended up in a different quality of service bucket on the service provider side. That went and is the ways that these types of things are being discovered. And so it may be worthwhile to have that not only available from a research perspective to do that, but to be general guidance for, these are the ways to detect when things are not behaving in the way that you are truly expecting, and having a lot better access to the lower level protocol statistics, and make sure that those are actually more available in a standardized way. So when somebody's using a library to interact with it, they can actually understand, we corrected for all of this underlying loss that may have existed from the network side, or this is the performance, or this is actually the bit rate that was perceived, and actually make recommendations around these. These may be valuable APIs that would exist for these purposes, rather than hoping that somebody might eventually correct for them. And the reason I mention this, I think, is something that's very important for this point in time, is that what I'm finding is that the subsequent generations of people, they're not familiar with looking at the wire level of many of the protocols, and they're not very familiar with actually even thinking about or dealing with systems that may not be memory safe anymore, because they're always using a higher level programming language. And so they're not spending a lot of time down in the bowels of these protocols, or bowels of the operating systems, to go and get that information, which may be available if you're down at that layer. But it's really essential, as mentioned from, from the gentleman over here from Meta, is that that's how they detected it, is, hey, performance actually got better.
Mm-hmm.
And that's how you quite often, or it's just not working at all. And that's how people are detecting these underlying things that need to be looked at.
How to detect these things and react to them is always super tricky, because like in my case and in many cases, it's a colleague of mine calls it the ouch ouch protocol. It's when someone picks up the phone and tells you your thing doesn't work, and there's like rarely a way to do that in band. But I see your point. That's interesting, because some of it can be done inside the stack, and a lot of when you're in the stack, how it works, and you're better equipped to do some things. But at the same time, you don't necessarily know, like, the bytes that are flowing, what does it mean? Whereas what the application cares about is, what is your video bit rate that you're seeing, and the quick seg might not necessarily know that.
Yeah, it's not necessarily about what the video bit rate is, because people likely don't care what the underlying application is, but what is the throughput of that stream? And that's something with, you take TCP and you do the math on the stats at the end of the period for the number of, segments transferred and the total bytes and where the windows went to and stuff like that. That data is helpful to understand what the underlying performance characteristics were of that. And so if you see something that is substantively different, and there's, I can set aside all the stuff about how to anonymize that data or whatever, but when you're actually a participant in one of the in the endpoints of it, either from the client side or the server side, you have a lot of data available in that moment, and calling out that that data is valuable in the protocol development part will help ensure that when implementers are writing the stacks, that they don't go and hide that so deep that it's hard to instrument later.
All right.
I really feel this is important for future protocols.
Yeah, sure.
Oh, no, we did quick. We're done now. Haven't you heard?
The one protocol to rule. Okay, so it sounds like we do have some interest in saying some concrete things, and there are some very specific things we can point to. Probably propose we can move on to our next item, since like it sounds like we have a thing to work on. We need to have a dedicated discussion. We can schedule a call for that more, but this is very helpful, I think.
Yeah, just one last thing before we move on. It sounds like there's interest in there being a document and there's a space and like some, the scope of it seems quite clear to me at least. Is anyone in the room interested in writing it and holding the pen here? We would probably have some of us IAB folks involved. It might be on the IAB stream, but if anyone's interested in working with us on this, here's an opportunity. I see Lucas.
Hello, Lucas Pardy, Cloudflare. I have interest in helping, but not being the only pen holder.
Sure, I
Totally
think
fair.
we'll probably want at least one IAB pen holder, but we can have, it would be fantastic to have other pen holders.
Consider me volunteered.
Any hands
Awesome.
make light pens.
Great. And the chairs will take an action item to schedule like an EDM interim to maybe focus on this specific topic.
I'll say the same thing, is not the pen holder, but I'm happy to participate.
Thanks.
Awesome.
Similar.
Awesome. Thank you. Cool. I love collaborative work. That's good. All right. So before we get to the stuff about finding implementations, there's one other point that Lucas and I have been talking about recently that I just wanted to share with this group as kind of an anecdote and see if there is, if there's something interesting here that we want to pull on. So it's actually about a bug that we found in Cloudflare Quiche through some testing recently. Yep. Unfortunately, there are bugs. And it was a case where we were catching in some tests, in some lab environments, we were catching some RFC protocol violations in Quick. I think it had been around for ever, probably.
Probably. Yeah, probably.
Yeah. And so, not to dive too much into the quick details, but essentially we were closing a stream, and when you close a stream, there's like a final size that tells you how much data had been there, and that was being sent by the server incorrectly, and so the clients were aborting the connections because the server was saying that it had sent fewer bytes than the client knew it had because the client had received more. So that should never happen. And specifically, this is something that was difficult for us to uncover, and we had been running a bunch of tests in kind of simulated profile environments where we were kind of like the India-China network profile of like something with a super high loss reordering based on kind of some real world measurements we had done and then recreating them in simulation. And in that type of environment, you see it a ton. And without that environment, you don't see it. And then we looked at kind of the real telemetry because eventually, so like normally you don't see this show up because the error rates are super, super low. It's like everything in the world is fine. But if you look for this problem, you do see it. And it's only what, Eric, you remember what was the percentage?
0.00 something percent.
Right, 0.001% of connections, but it's still significant at a global scale. And we do know that there are people in particular network environments who are going to be hitting this very commonly. So, a lot of that's just kind of a deployment and how do we test our implementations robustly. But I think there is some intersection here with, we do interrupt matrices for Quick, and we have these requirements, and we can miss these things for a very, very long time. And so I mean, one approach would be to, when we're writing down some requirements, we say like, this final size stuff, it matters for cases where you have a lot of reordering. Like that's what it's for. And so if you want to test this, if you want to make sure that you're doing the interop right on this, you need to make sure you have a test suite that does enough of the reordering, etc. So I don't know if that's useful, but it feels like something about the deployability and global deployability and making sure that we are doing the right thing by people in very different network environments and not just assuming it's always like the perfect networks we have at home is important to make sure as we're deploying something new.
Tommy, I think that speaks to the need for a lot of these statistics, that we're talking about. Is we need to know what percentage of the time, somewhat, if you're going to build a test environment or something for these, and look for that, even if it is rare that you see reordering. There are obviously cases where you're going to, where you might see that, and we often see things like duplicate packets and stuff like that as well. And on our CDN product, we actually have stats, so I can go and look at on a per network link basis, how many times we talk to like a client and saw, TCP retransmits or retransmits of something, of some sort, which is helpful to understand, is there actually a network loss problem? And is it a localized problem on our side, or is it, farther away on the client side? And so I think understanding that for that, for what you're talking about, the test suite, I think speaks to the need for the, for better data, at least a minimum data sharing when you're actually, doing the testing interop of the protocols to ensure that when you see these network behaviors that are not amazing, shall we say, that, you're not having the protocol go and degrade to the point where, either performance is poor or something else.
Cool. Dave.
Just brainstorming. One of the purposes of the hackathon is interop testing. So brainstorming, is there anything we can do and say future hackathons looking out a ways to encourage more interop testing? For example, is there any way that we can, because it's a sponsored event, right? So you could have people that are sponsors to help create things that you can't necessarily do in other situations, and people are in the room trying to test their protocols, right? And so could there be in the future, various networks that do, reordering, duplication, packet loss, and so on, to encourage people that are at the hackathon to do interop testing over these various weird technologies and things, right? So just brainstorming, and I know, Charles, you were saying, maybe we need to get a bigger room and stuff. And if you actually had some sort of a connectathon type component, bring your stuff here and connect it over these weird networks and stuff, then you probably would. But that's my brainstorming, as to maybe future ways to make the hackathon even another level of more useful than it is right now, which is already useful, right? But if you have ways, here's how to get on a network that does packet loss, reordering, duplication, whatever it is, then I wonder if people would use it. So that's my brainstorm.
Thank you. Love it. Lucas.
Follow on point. Yeah.
That's fine.
I can wait. Okay. So Charles Eckel, in case people don't know, with the hackathon, we do have the ability to set up these special networks, not only for you to use in the room, but to allow someone who's not at the IETF meeting to plug their server, whatever their equipment, into one of those special sort of isolated networks. And so we should be able to create these things.
We'll advertise right now. So.
Yeah, and maybe to when you try to use something, maybe it won't work quite as well as we think it does, but it seems to work pretty well. And it'd be great to try this out and just push the limits of what we're able to do. And I'm sure we can make the capabilities we have better if we have people using it, because a knock has been really, really helpful here.
Look, hello. I got a couple of points. Just on the walk over here, I was thinking about this issue in the broader context. Like, bugs are going to happen. We don't want them, but they can happen. And I think this isn't the only kind of bug specific to Quick that's related to stream handling and kind of resetting and the way that interacts with retransmissions and flow control and all that stuff. But like, that's kind of just boring details. Like, the thing I was wondering is there some kind of funny curve when we're implementing these protocols where we're very focused on the functionality and correctness in the first phase, where you need to, create a connection with a connection-oriented protocol, get the basics correct. You're very much focused on iteration of the document and keeping up to date with those things. Then you hit a point of kind of, I don't know, good enough. And then from that point on, you need to focus on the optimization to actually make this thing deployable, because it works, but it's so slow. that it's not that great. And then you get to the point where it's kind of good enough that you can deploy it properly, and then you interact with real use cases, real applications that are actually trying to thrash the protocol and use all of the features we developed. And then you start hitting these kinds of issues. One of the examples I can think of relates to like how progressive MP4 works in certain web browsers, and how they do this weird interaction thing where they open a stream, they reset it. You can try and design the tests for those things, but like no one did. Like the test was just run the thing and see what breaks. But the way it broke is really hard to diagnose, and many times I've heard the things just stop working and we don't know why, and then you need to go and investigate and debug these things. So it's just this like kind of fractal thing where you're trying to get to the edge of the universe, the end of the universe, but it's just like increasingly smaller and smaller steps. Just the amount of effort, and I think that's just the way it is. But anything that can help during quick. We have interrupt tools. Lots of people did develop some things like tooling to drop packets in certain intervals or arrangements like that. But we lacked like applications trying to use this thing for real, trying to saturate the connection, trying to soak it or thrash it at the same time as trying to probe at all of the gnarlier bits of the protocol, because it's too easy just to say, let's do a request or a response. The quick interrupt runner does have a high multiplexing test case, which is great, but it sends 100 bytes. And, we have these humongous numbers in quick. And I'd be very curious who's tested a flow that sent petabytes of data. I'm sure there's people there, and it probably works with the deployments that they have. But then you just chuck in some other clients, and then I don't know, there's all these other things. So that's that. And then the final point, with regards to the statistics, something when I used to work at the BBC in the public service, we had this idea of reachability of again, how much effort do you need to expend to get her 100% coverage on the internet and all the possible ways that the universe could work? It's like an infinite amount. It tends to infinity. So you can draw a line at some point, maybe, or try to, about what is decent reachability. And that's not maybe in terms of outright numbers, because 0.0001% is still people who can't do stuff potentially, and the impact there is still too big. And in commercial settings, sometimes that line can be, but in the settings where there's no money to be made anyway, you kind of have a mandate to get reachability to a certain population.
Martin.
So rare bugs happen all the time on the internet, and it sort of, to me, this really just highlights how that is definitely that's always the case. And if you've deployed anything that's less than perfect, someone will be affected by that. And I don't think I can agree with Dave here on this one. I don't think anything that we can do with the hackathon or anything is going to fix this problem. I don't think there's anything that with metrics that it's going to help this problem, other than helping us discover that this has happened. I just think that Cloudflare needed a better unit test for the code, and it's that prosaic. I discovered a similar sort of bug that required some incredible combination of reordering and packet loss and various other things, and only discovered it by fuzzing. Yes, it's unfortunate that we do get to this cycle, and I think, Lucas, you identified it really well. We have these sort of cycles where, can we get it working? Can we get it working good enough? And then good enough allows us to move on to can we make it performant? And there's that sort of natural progression in the development of a new implementation. And often that good enough point on the implementation side of things lets you get very long way down the path, and you can potentially miss a few things. And unfortunately, that's just not good enough really in practice. And we need to, I guess, exercise a little more engineering discipline when it comes to these things. And it's going to happen to everyone. That's the other thing. We've had massive catastrophic, the world locks up bugs that affect a lot of people because of those sorts of things as well. So I don't know that there's anything we can do here other than commiserate together, because this is just how the world is, unfortunately.
David?
Yeah,
After that cheery note.
Happy Wednesday, everyone. Someone get Martin another coffee. First, I want to just bring anecdote to like hammer on how these things happen. So Google has had a quick stack since there was Quick, and the Google Quick back in 2012 or 13, and we had a bug report a few years back where, so because we've had this stack for so long with so many tests and so much telemetry, and Chrome has a wide user base and so do Google servers, we've gotten it pretty darn bulletproof, or at least you'd think. And we had this bug where someone was, I forget even what it was. I think it was a website that allowed you to flash Android devices or something using the crazy web USB APIs, but that doesn't matter too much. And all of a sudden they're saying like, hey, our thing never works. Like half of our users are complaining like all of a sudden that this doesn't work. And it kind of coincided with us switching to a version of IETF Quick. And it took us a while to like track it down because everything was working. All our telemetry was green. But it was a very like similar to the bug that Lucas and Tommy were describing, where if you reached a case where your flow control blocked in a specific way that happened like twice in quick succession, you would lose the second unblock event, and you would end up just the client would just sit there being like, not telling the server it could send more, and the server's like, well, the client's not telling me anything. And it took quite a while to debug because we don't have like you can't run those, the server like things are anonymized. We can't say, oh, give us, anyway, all that to say, it was super hard. But now we added a test for this that specifically, once we figured out what the problem was, recreates the exact situation. And before the fix, the test fails. With the fix, it passes. And I wonder if, like, one of the things that I consider there are two values of EDM, apart from music, is one is we write these documents about how to do things better. And another is the work that we do outside of the documents. So for example, like adding implementation notes and things like that. A lot of these bugs are found after publication. And having maybe a place to say, here's a, list of fun stories of people blowing stuff up in creative ways that someone who comes new to the RFC can look at and say, oh, I should probably add a test for this in my test infrastructure, might be something that can help. I agree with Martin that there's no way to solve all of these. That's just a fact of life. But, small things that we can do that don't have an insanely high cost might help. And I think, this is a very pragmatic group. So just a thought.
Thank you. All right. And then Chris, and then we're going to switch over to our last topic.
Yeah, so I have a lot of thoughts. I'm not able to like clearly articulate them right now because I'm pretty wiped, but in general, I think everyone here is making like a good faith effort to like implement the protocols that we specify correctly. Like that goes without saying. However, like it occurs to me that it's as we go along, like specifying protocols and like doing experiments, interop tests and whatnot, like at some point we just kind of give up, for lack of a better phrase, and like don't try to do exhaustive testing and rely on like, just acceptance tests of a sort before we ship things, because we're facing like time pressure in the real world to like ship products or ship software. And like I wonder to what extent, to use Quick as like a relevant example, if we did not have this time pressure to like get this protocol out the door, would these bugs have appeared in production?
Yeah.
Well, yeah, and more importantly, if we didn't have time pressure, the protocol would never have shipped, and then it wouldn't have value.
Not to mention that without production, you wouldn't have been able to foresee a lot of these conditions because we can't foresee like every condition that happens in the world. Whereas you throw something at billions of users and billions of situations, and you're like, oh wow, there's a lot of stuff that happens on the internet.
Well, for sure. Like I guess what I'm observing and very poorly articulating is that like Quick is like uniquely complex compared to a lot of other protocols that are developed in the IETF. The state, people are shaking their head, but like take like Oblivious HTTP as a comparison. Like that is a very, very simple state machine. Very, very simple to implement. Very, very simple to test. And like this is an example where we did not exercise in tests in our particular case of Cloudflare's like all the branches that needed to be tested. Like, which is fine. Like that's the real world because like, you know, we can't exhaustively test everything, but like the complexity of the protocols as we specify them, I guess just seems to make this problem like you pretty difficult in practice to deal with. And I don't really have right now, at least, like coherent thoughts as to how we would like go about trying to do anything meaningful here to solve the problem, other than like, you know, stop publishing or like shipping software until it's like completely tested, which is not feasible for the reasons that Matt just like described. I'd like, I don't know, maybe I should like put the mic down because I'm not really making sense, I feel like, but yeah, I'm going to put the mic down because I feel like I'm not very making much sense. But
We can keep picking this up later.
yeah, sure.
Let's switch over to our last topic. Charles has prepared some slides. Do you want to share that?
I can share if that's easy.
Yeah, can you share?
Yeah.
David, are you able to approve in Midako?
Yeah.
Sorry, I see that you requested the screen, but I do not have the power.
Yeah, this laptop can, but they've intentionally disabled the mouse and keyboard for it, so we don't do
Oh,
that.
dang it. Oh no.
I mean, it's there's nothing technical in the slide, so I could just talk to it without people seeing on the.
Can we just plug your machine into this?
Yeah, does anyone have a USB keyboard?
Midako.
Yeah, let me ask
We did unplug from there yesterday, and I know we're not supposed to, but we put it into a different.
No.
But I don't know if that'd work for the Midako session. Actually, it would put it up on the screen here.
Midako. Can we get help in 318? G318.
All right, we put it in the chat too, so maybe Charles start, and then if we figure out the technical bits, we'll get them up for you.
Okay. So, you know, as was mentioned earlier, the idea here is to make it easier for people to find code and. Oh, sorry. Yep. So the idea here is to try to make it easier for people to find code related to the work we do in the IETF. You know, more specifically, internet drafts and even RFCs, you know, that have already been published. And the definition of code here is pretty broad. Taking some of the examples from the hackathon, you know, it could be what people would consider a reference implementation. It could just be a little tool that helps you with doing some testing for a new protocol. It could be a lot of things. And really any code that's going to help you at any point through implementing the protocol, deploying it, maintaining it, you know, seeing how it's working on the network. So to make it easier for people to find that, and specifically people who know about this association between, say, a draft and some code, to make it really easy for them to share that knowledge and kind of create a linkage so that those who are looking at the draft have an easy time finding the code, or those who happen to find the code on GitHub have an easy time, finding the relevant draft, and to get more participation that way, and to also speed up the whole standards process of defining, the new protocols, and the implementation process of getting it deployed. So really the requirement here is that the code meets kind of that that type of use case that I just mentioned, that it be publicly available, and ideally open source, but it doesn't even necessarily need to be, because it could still be useful without being open source. So there's various processes that we already have in place in the IETF. There's the implementation status section and an ID. We have some stuff around using Git and GitHub, right, for collaborating on drafts. And so we're already kind of making it easier for developers to work with us that way. And then we have the hackathon that obviously is focused on working on code. And oftentimes people will put links to drafts and code in their project description. So it's right there in the hackathon wiki. But there's problems with all of those, specifically with the hackathon. Those wikis kind of become, no one updates them afterwards, and not many people go to reference them, except maybe me when I go looking for things. So it's useful for the hackathon. It doesn't have that long life after that really helps people and is useful for people. So the draft, if you want to take a look at it, it just lays out a scheme, like a procedure, a proposal for how to do this. And it has to do with, first of all, setting up a GitHub repo for your draft for collaborating on it. In the README, you can then have some information about where this associated code is, and you can continually kind of add more information about that. Then in the data tracker, we're making use of the existing additional resource functionality to add tags, which are specifically for related implementations. And that's really the key thing there. I think that's where you put this association of either to point people to your README or to point them to a specific implementation. Then of course the implementation status in the draft is a useful thing you can put information there as well. And another thought was for RFCs, it may be handy to use errata to be able to update this after the fact, after an RFC is published. You can even help people find it that way. Although in the data tracker, the other mechanisms still work too. Assuming people find the draft through the data tracker, which is also a big assumption. So the slides show a bit how to do that if you're interested, how to use the related implementation field and how it shows up in the data tracker. I invite you to take a look at that if you like. I've been just kind of tracking with some help from people familiar with the data tracker APIs to see how this is progressing, how much use we're getting. The numbers aren't as good as I would hope. When I asked at IETF114, we had 14 occurrences of this. IETF115, we had 27. Just yesterday, we have 40. So it's increasing. But it's not like, I don't know, I expected it to increase faster and more. 40 is not bad, but so I think all the feedback I'm really getting is pretty positive. People think, yeah, this is a good idea. Yeah, it was helpful, but it still hasn't caught on quite as much as I would hope. One stumbling block that I've run into is if it's an individual draft, you can just go and edit it yourself. If it's a working group draft or an RFC, you have to go to your working group chair. And I don't know if it's even necessarily that people are not comfortable going to their chair, or maybe they just like, oh, I don't see how to do this. Charles explained it to me, but it's not working, and then they just forget about it. I think it's more the latter, which just makes me think maybe I can talk to the data tracker folks about adding something there. But I think the problem is you don't see the button that's like to edit it. So anyways, I wouldn't say what's laid out in the draft is perfect, but I think it is gaining a little bit of traction. I would really appreciate people's thoughts on, like, do I just keep kind of plugging along, or is there, do people have thoughts on a way to make this work better and accelerate it?
Dave Taylor, thanks for writing this. This is awesome. I'm one of your early adopters and stuff. We use related implementations and other working groups that I'm active participant in. The thing that I wanted to comment on, the phrase, and you talked about this a little bit, the code must be publicly available and preferably open source. I think, and so we may want to have a discussion at like, a working group chairs lunch or something, whether it's this IETF, the next IETF, or the one after that. But I think since you're writing the draft, what might be useful is guidance to chairs as to how to decide whether to accept a request to add something into there when it's not open source. Right, because is this like a product list or something like that? Because once a draft has been out there for a while, right, you can still update it for RFCs and stuff, right? Yeah. And so if you're a working group chair and you have some company that says, "Oh yeah, we have an implementation of this particular RFC, please add us in the related implementation," should we do that or not? And so really, it's kind of Wild West. There is no guidance for that, right? It's kind of figure it out, make some policy. And just having something, whatever the best practice is, I don't know what it is yet, right? But I'm saying among working group chairs that are using it, given that we have a bunch of us that are using it now, maybe we can come up with something. And I think your draft would be the right place to do that discussion. And then maybe it's a BCP or something. I don't know. So thanks.
Yeah.
Cool. I'm glad to hear we're using it more. I mean, I know 40 isn't a ton, but it's going up. And I know we haven't done like a ton of advertising, probably beyond Hackathon and working group chairs list. Definitely agree about the tooling. And do you remember who is being the tools team liaison now for IAB? Because we were just talking about who's going to do that.
Oh, we talked about this. I forget who volunteered yesterday.
Yeah, but we'll follow up in IAB, like, because I think.
By the way, we just got the slides approved, so now you can
Hey.
click the button. You can pick which one you have, Charles. Bit late, but
Or you can do your screen share. Yeah.
Okay.
thanks. But yes, the IB liaison of the tools team sounds like.
Yeah.
Chris, do you remember who? Yeah,
We'll
IB
figure it
liaison to
out.
the tools team is. Suresh doesn't remember either. All right, well, we'll take an action item.
Cindy knows. So I guess, what do people think about kind of adopting this? Charles, you've had the document around for a while. It's fairly straightforward, but I think there is. We don't need to have this be a complex or super deep document for it to be something useful. And so, do people think it's worth having something written down here that we can just share with the community? That's a way for people to be more aware. Dave?
Yes, absolutely. Although the question is whether the IAB stream is the right place. I don't know if the IAB can do BCPs, but I might actually argue that this could, depending on the content, it could even become BCP, and that's probably easiest in the IETF stream. AD sponsored or maybe generated, I'm not sure, right? But is it valuable? Absolutely, it's great already. So right now it's informational, right? But it could become BCP.
Yep.
Absolutely. Great. And certainly we can have things that we work on in this program that are not IAB stream. We can have a BCP that's AD sponsored. Yeah, that's great. Okay. So I think we'll take a follow-up to talk to the rest of the IB about it. We're going to have a EDM program review tomorrow anyway, and so we'll kind of figure out the right way forward. But I do think from what we're hearing, this is useful and we're getting some traction, but having a BCP would be a better way for people to find it and know about it. Yeah, that's great.
All right,
Okay.
thanks.
Cool. So 15 minutes until the next. Yeah. Please do.
I would say the only thing that I could imagine somebody arguing against the BCP is if somebody was saying, "Oh no, this changes so much, it should be in a wiki page," or something like that. But I think there's enough content that probably is stable enough, in my opinion, that it's worth a BCP, even if there's some portion of it that goes in a wiki page instead. So.
Some of the stuff you were pointing out, Dave,
that's in there right now is
Right.
about guidance to chairs on what links to include, and that type of stuff, I think, is going to, even if the details of tag names and stuff change, that advice is something worth writing down in a more evergreen way.
Right. As a working group chair, I would rather not be the person that somebody else is coming to say, by the way, please put my thing in there, and I have to try to figure it out. I would rather have something to fall back on. Well, we talked about this in the IETF, and the general consensus among all the chairs, even if you went to a different working group, you'd have the same answer. It's a lot more defensible. If I disagreed, if I did not want to put something in there, it's a lot easier to have text to fall back on than me trying to argue about it and then it sounding personal. So. And of course, if we said it is fine, right, then it gives me guidance that says, okay, well, and I'm just trying to say, if there was some case that I thought would not be appropriate because I didn't think it was publicly available, and they said, oh yeah, but we handed it to our 5 friends, okay, and says, well, okay, it's written down, it says publicly available, okay, well, what if we publish it as a product, or what if we put it up on this link that we don't advertise, whatever it is, right? And so I'd rather have something that's actually written down that I can refer to and fall back on. So.
Awesome. Thank you. All right. So 13 minutes until sessions begin. Do we want to just wrap up here? I think we had some great discussion input, and we have some work to do. So that's great. Thank you. Really appreciate everyone coming.
Do we have time for one other AOB type thing?
What's up?
So there's something that I've been observing that goes on, especially for those of us who have end up putting hardware filters in our networking devices, and what similar to talking about like the low level protocol and like hex, type stuff. What happens is I was in MPLS and somebody was talking about MPLS OAM thing and wanting to allocate a new port number for some new something. And it is helpful in a lot of the hardware filtering things if the port numbers are clustered, especially on bit boundaries, because then it takes up less space in the hardware for any filters going into the control plane. Yeah. And this seems like something when we talk about, the evolvability of protocols and stuff like that, if we're going to allocate port numbers and stuff, I know people love, hey, I'm going to pick this cute number for my protocol and stuff. But there's also help in kind of banding them, especially on bit boundaries, because if those are things that need to end up being pushed into a hardware filter, it takes up less space in the hardware. Right. And a lot of the devices these days only have a limited bit space to go and push those types of filters in to permit things.
So this is like in this particular example, because there could be, myriad examples
of course.
Layers.
Yeah.
Is like an IANA registry that has what type of review and allocation process?
Yeah.
Is it like there's some expert or better?
Exactly. But when we're talking about, if you're going to do, some sort of extension, you're going to add something new into something. If those port numbers are bounded, if there's kind of a pre-allocation or banding of it, that makes it a lot easier. Than us having to say, oh, well, I need to permit 22 for SSH, and I need to permit, 443, and then, I need to do that also for UDP, so I need to match multiple protocol numbers, and stuff like that. And because when those get compiled from the configuration into the hardware, they take up more space depending on how they get populated in there. And so if we think that, if you think that in the future there's going to be need to say, oh, well, we need to go from this to a range of ports for any new protocol, it's going to be helpful if those port numbers are potentially adjacent, because then the filters will be able to be efficient in the hardware. I know a lot of people are used to not dealing with resource constrained environments these days, but there are still resource constrained environments.
My initial impression is, it sounds like for whatever registry that is, that's good, advice to whoever the experts are.
But this does involve the ability to extend a protocol in the future if we're going to add some OAM or measurement or something, or whatever it is.
Yeah.
So, I don't know if we should want to take up.
Go in a minute, but that's thanks for bringing that up.
I was going to say it also suggests a weakness that could be exploited for good or for ill.
Yes. Yeah. Yeah.
I put these really highly valuable protocols in a nice block.
Yep. And
then put an extra protocol in that maybe the network would rather I not use right in the slot.
Yep. Do you want to, if you want, so we can discuss more, you shoot an email to the list too with your thoughts on. We do have mailing lists. We don't use them much, but we do have them.
Yeah, this was just something that
Yeah,
kind of
yeah.
came up yesterday. I haven't had
That's good,
time
yeah.
to send
Yeah.
a message on, but I wasn't, it sounds like that the privacy area of the IETF will have a problem with that. And so the issue is that for those of us who are actually securing the network devices, that means that we won't be able to do that, unfortunately. If somebody's going to say, oh, well, you made it well known.
All righty. I think that's it for us then. Thanks, everyone.
Yeah, thank you. Oh, my next one's right next door. How convenient.
Well, I'm just looking through GitHub issues and talking about periods in the DNS. I think it's a wonderful idea. So you put them on the streets. So period is a separator. But it can also appear inside the line. Yep. Yep.
And rather than being an individual GitHub repository, like there's a
Depends on where you are.
somewhere else. So you can still refer to it, but I think you're gonna have.
Yeah. Chris is like, have you done your slides? I'm doing them right now. I'm really sorry, but we were out last night until like 4 a.m. I'm very
Okay,
surprised I'm even here.
one of the thoughts with pointing people, like setting up a GitHub repo and letting them do a README is that you can expand.
I'm
Like
nearly
you could
done,
have
like-
10 different things you want to point out. One of them could be what you just described.
Yeah.
Am I understanding your?
Yeah, I think like.
So it doesn't need to be to a GitHub repo that has code.
Yeah.
It could be something.
Yeah, oh, that's perfectly fine. It's just I want to be clear from your.
Okay,
Yeah,
I
it's a-
probably